Hey there everybody, Mr. Bacon here. In this video we're going to be solving quadratics by a method called completing the square. Now completing the square is a great method if you want to quickly get an answer. The process in order to do it is kind of cumbersome at first, just as a heads up. Completing the square is also very great in case our answer isn't a nice, clean, pretty integer, which is what factoring would generally give us. So, before we get into that, let's just take a second to recall what perfect square trinomials mean. So a perfect square trinomial is when you have a three-term expression, and the last term is a perfect square, meaning I can take the square root of it. Now, in order to double check if in fact this is a perfect square trinomial, this last term has to be positive and a perfect square, and whatever the square root of this number is, our b term, our middle term, or the linear term, has to be twice as big as the square root. So if I look at this, the square root of 9 is 3, and 6 is twice as big as 3, so this would work as a perfect square trinomial. And if I were to factor this thing out, this would be x plus 3 times another x plus 3. Or more simply put, x plus 3 quantity squared. So as we discussed, the square root of 9 gave us that 3, but half of 6 was also 3. So it kind of has to work for both facets there. All right, next one. X squared plus 20x plus 100. All right, this last term is a perfect square. I can take the square root of 100. It's positive, so the square root of 100 is going to be 10. And if that middle term, the bx term, or the linear term, is twice as big as the square root, that means we can use our little shortcut here. Let's see, square root of 100 is 10, twice 10 is 20, so we're good to go. We can write this as x plus 10 quantity squared. And that's what this thing would look like in factored form. Next up. See, I'm looking at the last term here. It's positive and it's a perfect square. The square root of 25 is 5. And double 5, twice of 5 is 10. But this here is saying it's a negative 10. Because I want to be able to write an x and a 5 quantity squared, right? Because that would match the square root of 5, or square root of 25 is 5, and then half of 10 is 5. But this negative is kind of throwing me off. I can't put a plus in the middle, but if I put a minus sign there, half of a negative 10 is a negative 5, so that kind of works out. But if I squared a negative 5 times another negative 5, if I'm visualizing what would happen when this thing foils out, when we're multiplying the negative 5s together, that would still be a positive 25. So we're good to go. In general, the symbol right here, the sign, will always match. So the sign in front of the b term will match what's inside the factor. All right, the last one is going to look scary, but it's really not too bad. If I'm looking at the last term, 9/4, that's a perfect square and it's positive. To take the square root of a fraction, just take the square root of the top, which is 3, and the square root of the bottom, which is 2. That's all you have to do. But we also have to make sure that 3 over 2, 3 halves, is that half as big as 3? Well, if I divided 3 by 2, yeah, I'll get 3 over 2. That's exactly what we have. So that checks out. So this would factor down into x plus 3 halves quantity squared. All right. Now let's get into subsets of numbers. Typically, we deal with real numbers. That's almost always where we kind of land. And the reason for that is those are numbers that we can easily identify, like on a number line or something like that. Real numbers will fall into two subsets. They're either rational, meaning they can be written as a ratio or a fraction, so 3 halves, 1/5, 2/7, so on and so on. Or they're irrational. Irrational means it's not possible to write it as a clean, pretty fraction. So a lot of times with irrational numbers, that's where you'll get, like square root of 2 is very common. Pi is a very popular irrational number. The number e, which we'll get into later on in the school year, is a very popular irrational number. One thing that makes irrational numbers irrational is the fact that they cannot be written as a fraction or as a decimal that is non-repeating and non-terminating. So that means it's a decimal that goes on forever and ever and ever and ever and ever and ever and ever with no discernible pattern. And then we have this side over here of imaginary numbers. And imaginary numbers show up whenever you take the square root of a negative number. So I'm just going to use -7. That results in an imaginary value because the imaginary unit is just the square root of -1. All right, so let's solve quadratics here. For these problems, we're going to be solving all of these by taking square roots. Now, you're allowed to take the square root if you only see the letter x one time and it's being squared. Essentially, we are missing the bx term, that linear term. It's gone. We don't have it. If that linear term was in there, then we'd have to go through and do factoring or completing the square quadratic formula, what have you. So for all of these equations, what we're going to try to do is we're going to try to isolate that x squared term. And we're going to isolate that as if it were just an x. And once we have that squared piece all by itself, we'll take the square root and we'll solve from there. You'll notice down here on the bottom three, I highlighted the entire parenthesis chunk. The reason for that is this entire factor term is being squared, and since x is part of that, I have to isolate that entire portion. Okay, so let's get started here, number one. Number one, if I'm trying to isolate, first thing I'll do is subtract the 10 to the other side. So that'll give me 36 over there. Then I'll divide by 4, so I get x squared equals 9. And from here to solve, to get rid of a squared, I'd take the square root. The square root of 9 is 3. Or it's -3, it's one of the two. So in order to solve that, or to show that, I need to write this as positive or -3, a little plus or minus symbol in front. General rule of thumb, if you see x squared, if you have an exponent of 2, you should expect 2 answers. So my 2 answers here are +3 and -3. Number 2, 3x squared minus 5 equals 25. First thing we'll do is move that 5 over, so 3x squared equals 30. Now let's divide out the 3, so x squared equals 10. And from here, to get rid of that squared, we'll use a square root. 10 does not have a clean square root, so we'll just leave it as positive or negative, plus or minus, rad 10. We'll just leave it as the square root of 10. If I were to try to write that as a decimal, I'd get 3 point blah, 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 blah. But at some point, I would have to round it. And if I round a decimal, it is now a terminating decimal, which means I've rationalized it when it's not a rational number. All right, number 3. 3x squared plus 16 equals 1. First and foremost, let's get rid of that 16. So we'll subtract that to the other side and get -15 over there. Then we'll divide out the 3. So x squared equals -5. We'll square root. On this one, I'm having a square root of a negative. So I know that the I is going to come into play. I know we're going to have 2 answers. So it's going to be I times the square root of 5. That's just a cleaner way of writing. Instead of a negative underneath the radical, we write it as an I out front. And we throw the plus or minus symbol to indicate that, hey, there are 2 square roots there. All right, on to the next. All right, with these problems, anytime you have your x hidden within a parenthesis term, you can't just use that shortcut of going plus minus an answer. It's not going to work that way. It would be a lot cooler if it did, but it won't. What we're going to have to do with these is get rid of the squared, because it's already isolated. I don't have like a +7 or anything to get rid of. And once we have that squared gone, once we have the squared gone, we'll have two separate equations essentially. So I'm going to start off by taking the square root of each side. Now the square root of 100 is 10, but it's also negative 10. So I'm going to need to set this up as two separate equations. X minus 4 is equal to 10, or x minus 4 is equal to negative 10. So I just took the stuff that was in parentheses, and that's what goes on the left side of these equations. I don't need the parentheses anymore because those are just handling the squared, but we got rid of the squared by using the square root. All right. So now I'd add 4 to the other side, and I'd get 14, or I'd get negative 6. So those are my two answers. You'll notice they're not the same, so I couldn't just say plus or minus 14. All right, number 5. First and foremost, let's get that 8 to the other side. So x plus 1 quantity squared equals 8. Then we'll take the square root. So x plus 1 equals positive or negative rad 8. Square root of 8 is not a clean number, so I'm just going to leave it like that. From here, this is where I have to set up two separate equations, right? I'm going to have x plus 1 equals the positive rad 8, and then x plus 1 equals the negative rad 8. For each of these, we'll just move the 1 to the other side. So x equals negative 1 plus rad 8. X equals negative 1 minus rad 8. A cleaner way to write that would probably be x equals negative 1 plus or minus rad 8. That way it's just kind of like a one-stop shop. It's not going to be wrong if you write it as two separate, just so you know. All right, last and final one. Right here, the square term is already isolated, so let's go ahead and square root. So we'll have, let's see, that'd be 7 or negative 7. And then when we go through to solve these, on this first one here, we'll subtract the 1 over. Actually, we'll subtract 1 over on both sides. This would be 2x equals 6, so x equals 3. If I divide out the 2. 2x equals negative 8, divide by 2, x is negative 4. Awesome. All right, now let's use that to start solving by the process of completing the square. So completing the square is when you start off by having a binomial, two terms, expression. So you have the x squared, the quadratic term, and the bx, the linear term. And you're going to see, what do I need to have as my constant value? What do I want to have as that c value in order to give me permission to write it as a perfect square factored trinomial? Essentially, what we're doing is these problems that we started off with, we're going to be given the first two terms, and then we're going to say, what do we need to be here in order for us to factor? So that's what's going to happen here. Now, the way you do that is you just take your linear term, your bx, you take that number, chop it in half, and square it. So that's what this is here, b chopped in half, then we squared it. Once you've done that, you're able to factor it as x plus whatever b chopped in half was, quantity squared. So what we're going to do here is we're going to go through, and we are just going to fill in that blank space and then write it in factored form. Okay? So first one, I need to figure out half of 8 and then square it. Well, half of 8 is 4. If I square that, I get 16. Number 2, half of 2 is 1. If I square that, I get 1. Number 3, half of 20, or negative 20, is negative 10. If I square that, I get 100. Number 4, half of 5 is, well, that's just going to be 5 over 2. So 5 halves. And if I square that, that'd be 25 over 4. On number 5, there's technically a 1 attached here, so if it helps you to write that in there, go ahead and write that in there. Half of 1 is 1/2. If I just divide by 2, I throw a 2 under it. Square that, and I'll get 1/4. So you square the top, square the bottom. And last one, we have 100. Half of 100 is 50. And then if we square 50, we would get 2,500. You'll notice all of these numbers in the C value, those are always going to be positive, right? Because they come from being squared. So now let's write these in factored form. When you write it in factored form, it's always going to start off with an x plus or x minus. And you're just going to steal whatever that sign was there. So for number 1, it's going to be a plus. And then whatever number goes in there, that quantity here is going to be squared on the outside. Now to fill in this blank, you're just taking whatever that number, when you chopped b in half, was that you squared. So we chopped 8 in half to get 4, and then squared that to get 16. So this would be a 4. Next one, we chopped a positive 2 in half to get a positive 1, and squared that. So the positive 1 goes here. Number 3, we chopped a negative 20 in half to get a negative 10. So this would be a negative 10 right here, and that's what we squared to get 100. Number 4, cool, I already wrote this down. We chopped 5 in half to get 5 halves, so this would just be x plus 5 halves, quantity squared. Number 5 would be x minus 1 half, quantity squared. Because again, 1 chopped in half is 1 half. We squared that to get 1/4. And last, this would be x minus 50, quantity squared. All right. So now let's solve by completing the square. If you guys want to pause the video here and maybe jot down these steps or review the steps before we get in the problem, that is not going to be a bad move. All right, so let's go through and solve some of these, shall we? We're going to solve by completing the square, then classify solutions. Ooh, I didn't realize we had to classify solutions. I forgot to do that over here. My bad. All right, so quickly, it's either rational or irrational. That would be rational, irrational, irrational. Actually, that's also imaginary as well. That's rational, irrational, and rational. All right. Sorry, didn't mean to backtrack like that. All right, here we go. We're going to solve by completing the square. So when we complete the square, our goal is to focus on these first two terms, so the x squared minus 6x, and play a little game of what if, right? What do we want to see next to that 6? What do I want to see in this little blank here so that I could write this in factored form as x plus or x minus something squared? Now, I can't just throw a blank in there all willy-nilly, right? Because that'll unbalance my equation. So what I'm going to have to do is whatever gets added in here, I'm also going to have to do the same thing to the other side of the equation to make sure I maintain balance. Some of you might be asking, hey dude, there's a 4 here. What the h? Where did that thing go? Well, I don't want that constant term there, so I'm just going to throw that to the other side. So I'm just going to subtract that over. So right now, here's what our line of work should look like. So x squared minus 6x plus some mystery number equals negative 4 plus same mystery number. Now the way we get this value is we're going to take 6 and we're going to chop that in half. So it's going to be a minus 3 down there. Remember, the signs will always match, the minus right there. And then we are going to take that number and square it to fill in this blank. So 3 squared is a positive 9. From here, we'll simplify the right-hand side of the equal sign. Negative 4 plus 9 is 5. Well, this should look just like one of these styles of equations, right? We've already solved these. It's going to be no different. So x minus 3 quantity squared equals 5. I'll square root each side to get rid of that squared. So x minus 3 equals plus or minus radical 5. Move the 3 to the other side. X equals 3 plus or minus square root of 5. Shazam, we're done. du and done. Next step, number dos. That's Spanish for number 2. I've got x squared plus 4x equals negative 5. I want to solve this thing for x. Well, just like before, what I'm going to do is take the quadratic term and the linear term and keep those on the left-hand side of the equal sign. The constant, or plain old number, I want over on the right-hand side. So now what we're going to do is we're going to figure out, okay, what is half of 4? Because that number is going to have to go into the parentheses when we write this as x plus or x minus something squared. Well, half of 4 is 2. And I know that the constant value over here has to be the squared form of whatever this was. So squared form of this. So 2 squared, hey, that's also 4. Positive 4, mind you. Let's see, this was a plus sign, so that's going to be a plus sign here. All right, let's make this thing pretty. Negative 5 plus 4 is negative 1. Excuse me. And now we'll just solve like we've been solving. So we have x plus 2 equals square root of negative 1. That's just plus or minus I. So this would be x equals negative 2 if I move that over to the other side, plus or minus I. Done. Oops. Here I am forgetting to do more stuff. Classify the solutions. Here, irrational, because it's got the radical. This would be an imaginary solution, which is also by default going to be irrational. All right, number 3. You may notice we've got a coefficient here. We're not too thrilled about those. There are 2 ways to handle it. Way number 1, if you can divide everything, and I mean everything from both sides, by that coefficient, in this case 2, do it. That, however, will not be the case. So we're going to do this the quote-unquote more challenging way, just that way you're prepared when you see one that's presented like this. So what we're going to do is we're going to kind of keep it how we've been doing before. We're going to keep our a and our b terms, the squared and the plain old x. And then we're going to move the 2 to the other side. This is going to be positive 2 over there. And now what we're going to do on the left is we're going to factor out a GCF. So I'm going to call that 2, and then x squared plus 2x, and I'll leave a blank. And over here, should look pretty familiar. So now we're going to do our completing the square process and say, okay, what number would have to go into the blank here? We take half of 2 and then square it. Half of 2 is a 1, squared is a 1. But now, here's where I have to be careful. I can't just add a 1 to the other side because this isn't technically a 1. It's a 1 times this value of 2 on the outside. So I'd have to think, okay, what is 2 times 1? Well, that's 2. So I'd have to add 2 to the other side here, which would give me 4. From here, we'll square root. I get x plus 1 equals square root of 4 plus or minus 2. So x equals negative 1 plus or minus 2. Negative 1 plus 2 is 1. Negative 1 minus 2 is negative 3. All right, last one in this problem set. This one's nice and straightforward. We'll keep the x squared and the 8x over on the left. We'll kick the negative 6. We'll kick the 6 to the right side. It becomes negative when we do that. I didn't leave a blank space. Silly me, what am I doing? What am I doing? So then this would be x squared plus 8x blank, negative 6 blank. Let's see, half of 8 is 4, so it'll go in the parentheses down there. And then squared is 16. 16. This would be x plus 4. Remember, this number is always half of that. Quantity squared equals, that'd be 10. Negative 6 plus 16. We'll square root both sides. X plus 4 equals positive negative rad 10, so it's going to be irrational. x is -4 plus or minus square root of 10. All right, home stretch here. Home flippin' stretch. Actually, you know what? We're only going to do number 5. Number 6 is the exact same thing as number 3, just with a different coefficient. So we'll just do number 5 in the interest of time. You'll have the completed notes PDF stuff, so you can see what that would look like. All right, number 5, I'm going to move the 1 to the other side. So we have x squared minus 2x, blank space, equals 3. 4 minus 1 is 3, blank space. And now we're doing our completing the square process. Half of -2 is going to be a -1. And then square that is a positive 1. So plus 1, plus 1. In the parentheses here, we'll have x minus 1. Because remember, half of -2 is -1. Equals 3 plus 1 is 4. Square root each side. X minus 1 equals positive or -2. If I add 1 to the other side, x equals 1 plus or minus 2, therefore x equals 3, or x equals -1. And those would be rational. All right, cool. Like I said, number 6, it'll be on the PDF of the completed notes, but it's the same as what you've been seeing. Sorry for the length of this one, but hopefully you felt some level of confidence where you're able to kind of skip ahead and focus on what you needed. You know the drill. If you have any questions, let me know. And as always, folks, good luck, have fun, be safe, roll tide.